This video will cover section 10.2, Introduction to Conics, and the first one that we will discuss will be parabolas. The objectives for this section will be to recognize a conic as the intersection of a plane and a double nap cone. I will be showing you something from your ebook that will perfectly explain what the first objective means. Then to write equations of parabolas in standard form. And here we say equations, not only functions, because we're going to have parabolas that will be opening upward and downward, like in chapter 2. And we're going to have the ones that open sideways, either to the right or to the left. And so those are not considered functions. Think about it. If you were to draw a vertical line test, it will definitely not pass it. And then we will also use the reflective property of parabolas to solve some real life problems. And then we'll learn some other terminology. So here is a quick explanation, and I will show you a video in a minute, and I will also show you how to access your ebook in case you don't know. So a conic or a conic section, or simply a conic, is the intersection of a plane of a double nap cone, like you see there. They're touching with their vertex. As you can see in the figure 10.7. And if you were to intersect a plane, not an airplane, but like a paper, to cut through it, if it was in this way, it will be a circle. If it was slanted, it will be an ellipse. And if it was a parabola, if the cut was this way, it will produce a parabola in a two-dimensional plane. And then if we do a cut that is perpendicular to the base of those cones, we will get the hyperbola. So these four things, in fact, circle was part of chapter 1, I think like 1.9. So parabola will be today's, this section's main subject. And then we will, the following sections, we will cover the ellipse and the hyperbola. Also, in the video that will come up in a minute, we have this, if the cut was made right at the intersection, you will have a point on the plane. If the cut was made this way, you will have a line. And if the cut was made right in the middle of the cones in a vertical way, it will cause two lines. So those three, a point, a line, and two intersected lines, are going to be mentioned as the degenerate conic in the video. So, and also one thing that the video explains, I will not play the whole thing, but I will show you how to find it, is how to find if the equation is an ellipse, a circle, a parabola, or a hyperbola based on the coefficients that you see here. So A, B, C, D, E, and F. You will also hear the word locus, which is a collection of points satisfying whichever geometric property that we will be discussing. So I'm going to switch to the video. So I believe this is how you see WebAssign when you go in, and you can see that you have two assignments due today, your quiz 4 and probability. So what I want you to do is find on the top options the one that says my ebooks. So you will click there and we go to that one. So then you will select chapter 10. That is our last chapter. And then we're gonna go, well, here I was under exercises, and since we're here, I want to show you that you could always I'm gonna switch my view a little bit. So for certain exercises, you could find the answers on your ebook. So I actually just found that out today. I thought it was very cool, you know, if I was a student, but I just wanted to share that tip with you. So some of the questions have the answer, and if you're doing your homework on website, you might have different numbers, you know, but sometimes it does help to have an example or the answer of something else. So going back, where I want to go is just to the actual introduction. So that will be Introduction to Conics. And we have to start at 10.2. I'm not skipping 10.1. That's just how it is. And you could see here your ebook. I really hope you are familiar with it. So the that is those two are the images that we went over on the PowerPoint. And so the equations for those are actually the equations that are that you could see here. We have the equation for the circle, and then we have the equation for the parabola that we already know that opens either up or down, upward or downward. And this is how the equation of a parabola that opens sideways will look. So you could see the y square is the one that, the y is the variable that will be square. Then we have the ellipse. So we have this type of ellipse that looks wider. So the horizontal axis happens to be the main axis. And then we have the ellipse that opens, not open, sorry, for which the vertical axis is the major axis. And then we have the equations of the hyperbolas. And these are the drawings that we will be doing, the graphs. In fact, and here finally is the hyperbola for which the major axis is the x-axis. So you could see that is symmetric with respect to the x-axis. The one before is symmetric with respect to the y-axis. And so these equations are very interesting. As you can see, we have some fractions here. The difference between an ellipse and a hyperbola equation is that you have a positive for ellipse and a negative for hyperbola. And also another big difference to point out is that with an ellipse, you decide or you will learn how to tell just by looking at it if it will be um, like a horizontal ellipse or a vertical ellipse, and also with the hyperbola. But we will save that for next section. So if you are interested, this professor does a very nice job at explaining, you know, all those little details about those equations. So what I'm gonna do is play another video, but I'm gonna pause this video um, so I can find it. Okay, so I found it. I found the video, but first I want to show you how you can find it so that you can finish watching it on your own. And also you could use the tool to help you out with some questions from your homework. So to navigate the pages, of course, I have to click on that arrow. So I'm going to do that. And we go to the next page. Actually, I think we're already on that page. Yeah. So that was the first page where we were at. Then go to the second page for this section. And you are going to click on not the first animation, but the second one for parabola. And so that will be here, shifted conics. If you want more information, you could always watch these videos, and they're actually way shorter than mine, so you might like those better. So I'm going to go there to shifted conics, and I'm just going to adjust the recorder here. And so you could see here the equations, and this is the standard form of those equations. So they all have a general form and a standard form. So the standard form is written that way, and based on those letters or that are representing the coefficients, then you could tell what kind of conic we have. So I'm just going to play the very beginning. Okay, so I paused that video. So if you go to the Explore tool, you could play around with the coefficients here. So for example, if you were to enter, let's say, a 1 for x squared, and then we make the coefficient for y squared a 0, and we make the coefficient for x, let's say we make it a 1 as well. So if we press enter for that, you can see we get a parabola that is opening down. Now, what happens if we change that to a -1? So we do that, and then you could see that it is opening up. And that is because if we were to take this one to the right side, so we will have y equals, then the negative x squared will become positive x squared. So that's why. Now on with this tool, I believe you can zoom in. Actually, well, that is explained on the video, so you should finish watching it. But yes, you can do that. You could also shift, as you could see here, we have the letter representing A. Well, letter A representing this one here. And then we have the letter H representing this part of the vertex or the horizontal shift of it. And then we have K, which is the value for the vertical shift. So you could also see here vertex, you could see focus, you could see the axis of symmetry. So it is in this other word that we're going to study called the directrix. So you could increase the value of H, and so as you can see, the parabola shifted up. Now, what would it look if it was a, I wish I could just reset this. Okay. What would it be if it was a sideways parabola? So for those, we will have things such as, let's make x squared equal to 0. Then we'll make y squared equal to 1. And let's make the coefficient for x just a 0 for now, so I can show you the parent function. And then let's change this y to 0. And let's not put a constant term for now. And what I want to do is make x equal to 1. Okay. So let's see if we could graph that. So that will be with the coefficient of 1 for y squared and a coefficient of 1 for x. The rest are zeros. And let's say that I wanted to change so that the parabola is opening to the right instead. Then I could do, I could just simply change this one to -1. and press enter, and you could see now it is opening on the other side. So that is just a quick example for that. You could see it has a vertex at 0, 0. And then we're going to learn this other thing called the focus, and we're going to learn the importance of it. And the axis of symmetry will be the y-axis, I'm sorry, the x-axis, or the line y equals 0, which is the x-axis. So those are some of the things that you could do here. There are some practice questions as well that you could go over if you were to need more practice. For example, a circle is going to be the set of points, and remember we were talking before those videos or the interactive, we were talking about the collection of all points, the locus, and that in the circle it will be the collection of all the points that are equidistant, so they have the same distance from a fixed point h comma k, which is actually the center of the circle. And this leads to that equation of the circle. So just to give you some examples, if your circle was at the origin, with the center at the origin, it will be something like this. So like x minus 0 square plus y minus 0 square, and that equals to r square. So, and here instead of h, I was supposed to write a 0. So that, of course, reduces to x squared plus y squared. And let's just give a value to our radius. So let's say we want the radius to be 4. So it will be 4 squared. Now, if the circle was shifted, let's say like x minus 3 square equals y minus 5 square equals r square, then that circle will have its center right at where the h and k numbers are. So for h, that will be the horizontal coordinate of the center, or the x value. And for the y value of the center, we will take this number that is representing k. So that will be positive 5. And I know I have two negatives there, but the negatives are actually part of the equation. And it's kind of like when you learn about horizontal shifting, it was counterintuitive because of that negative. So if you had a circle with the following equation, let's say x plus 4 square, and let's say we have here an y minus 2 square, and here r square. So what you have in reality is x and then minus, and then you will have a negative 4. So the value for h, it is negative 4. And so for that reason, that particular circle will have its center at negative 4 comma positive 2. So the value for k is just positive 2. And if you see a plus here, what it means is that you had a double negative, and so you should always take the opposite of the number that you see here. So if you have x plus 4, then the x coordinate of the vertex, or the center, I'm sorry, will be negative 4. So that's just a quick summary of the circle. Now from chapter 2 of your textbook, or pre-K 1, you had a chapter about polynomials. Parabolas was part of the polynomials. So you learned about the standard and the general form of the parabola. And you learn how to tell if it opens upward or downward. So upward was something that, it looks like that. It opens up, and that happened whenever the coefficient for the x square was greater than 0. And the parabola opened downward if the lead coefficient was less than 0. And of course, you also knew that a couldn't equal 0 because then you wouldn't have a parabola. So those were some of the things that you learned there. You also learned about the vertex, and that was either the maximum or the minimum point of the parabola. And based on that, you learn how to find certain things. So now we're going to look at a different definition of parabola that, of course, it is true for this type of parabolas, but it is also true for the other type that we're going to learn. And we have the following definition. So a parabola is the set of all points in a fixed plane. So the set of all points will be what you see here as the solid line. That's what we're talking about. That are equidistant from a fixed line called the directrix. So the directrix is a fixed line, and that is here. And also a fixed point, which is called the focus. Here's the focus, not on the line. So the focus, as you can see, is not on the yellow part. It's not on the curve of the graph. The vertex is the midpoint between the focus and the directrix. So if you notice the distance from the focus to the directrix, and if you cut that in half, you will see it will be right there at the vertex. So that is the vertex. I think you were already familiar with it, but now so you know that, please add this to your knowledge, the midpoint between the focus and the directrix. So sometimes you might be given the equation of the directrix and you have to figure out where the vertex is, or you may be given the focus, find where the vertex is, or any combination like that. So it is important to know that relationship, that the vertex will always be halfway between the focus and the directrix, or also to know that the distance from the focus to the vertex is the same distance from the vertex to the directrix. And then finally, what else do I have here? The axis of the parabola is the line passing through the focus and the vertex. And so that will be this line here. We could also refer to that as the, well, axis or axis of symmetry. Also, just so you know how it is determined that the points are equidistant, they have the same distance from the any point on the graph, such as that one, for example. It had the same distance from the graph to the directrix, and the graph, that point on the graph to the focus. Those two are the same. That's why they're both called D2. Also, we can look at this other case. So for D1, this distance 1, we are looking at this point here, and the distance from that point to the directrix is the same from that point to the focus. And just so you know, it needs to be perpendicular with the directrix, and that's why we have that 90-degree angle. Note that a parabola is symmetric with respect to its axis. Using the definition of a parabola, you can derive the following standard form of the equation of the parabola whose directrix is parallel to the x-axis or to the y-axis. So just like the circle had that equation, x minus h squared plus y minus k square and r square. Remember that was for the circle. So for the parabola, we have these two equations. And just get used to it. H will always go with x, as you could see here. And k will always go with y. Now, the variable that gets square will tell you if the parabola will be like the ones you know from pre-cal 1 or chapter 2. That will be the case of the first one. You see the x is the one being square. And the second equation is telling you that the y is the one being square, as you could see there. So that is how we tell them apart. And same thing as with the circle. H and K will tell you the shifting of those two. If H and K are 0, like the case that you see here for 3, well, for this equations here, that is because the vertex is at 0, 0, at the origin, as you can see written here. So that's why we only have x squared equals, and then you could see your y. And the variable, we have a new letter here. The variable lowercase p is gonna represent the one that I'm highlighting here. It's going to represent units that are from the focus. Well, okay, I'm going to read the statement instead. The focus lies on the x-axis, p units from the vertex. So it will be the distance from, just like we had on the previous drawing. If here's the vertex, and let's say that here's the focus, then the value for P will be the distance from the vertex to the focus. So it will be this part right here. From here to here. From the focus, the point in green, to the vertex, the point in black. And so that is where we get that value from. Sometimes that would be given to us. Sometimes we might have to find it by calculating how far or the distance between one point and the other. So here we have some examples. So the vertex, you could see that it could be the maximum or the minimum point of a parabola. Also, we have the line, the directrix, and that will be here. So actually, this paper, this slide and the previous one, this is what you want to have with you when you take the exams and when you do quizzes and when you do your homework. These formulas are very important because sometimes you will be asked to find the equation of the parabola, but other times you will be asked to find the directrix. And so the directrix will depend. If you have a parabola of this nature, the directrix will be a line that will be perpendicular to the axis of symmetry. So in this case, to the y-axis, perpendicular. And so in that case, it will be a horizontal line. And that is why we have y equals. Now, if you have the other type of parabola, the ones that open sideways, let's see, like something like that, the vertex will be here. The focus might be here, and then the directrix is going to be right here. So that line is a vertical line, and it's gonna be with the equation x equals to a number. Now, how would you find that number? So you're gonna have to look at these notes and or make a formula sheet, because you will have to consider the value that we discussed, p, and the value of h, in this case, if you have that type of parabola. So, and the values of h and k come from here, from the vertex. Okay, so also here, there are some formulas that you need to take into consideration, and it depends what kind of parabola you're dealing with. So if you are dealing with the top two parabolas, the focus is found with the same formula, as you can see. But if you are dealing with the sideways parabolas, then the way you find the focus is different. So please make sure you take notes, write this down. Sometimes just seeing it on the slides or on the video is not enough, and it shows on your grades. So please try to take this last chapter serious, and do good on your exam. So that is how you find focus. Also, for the directrix, we have different formulas. So for upward downward parabola, the directrix could be found by using that formula. And for the other two types, the sideways type, we have a completely different formula here. And so remember, they're vertical lines. These are the vertical lines that we're talking about. And if you have to graph them on WebAssign, make sure you make them dotted or dashed so that they don't get counted wrong. So, because they're not actually part of the graph, they're not part of the collection of points. Only the solid line is the parabola. So that is the directrix here and here. And in the case of the upward and downward parabolas, they are horizontal lines. And so that's why the equation is y equals to a number. So all of that is going to come into play when you're doing your homework. Every single formula is important. And let's see. How do you know if you will have a opening to the right or to the left? Well, that's going to come from the value that you have for P. And that will be if it's positive or if it's negative. And we will see that in the following examples. So example 1, it says find the standard form of the equation of the parabola with the vertex at the origin. So remember that right away tells us at 0, 0. And with the focus at 2, 0. So if we were to graph those 2 points on the XY axis, pretend we don't have this thing yet, so I'm just going to cover it for now. So if we were to graph a point here for the origin and then a point for the focus, which will be at 2, 0, 1, 2, that will tell me that my parabola is going to be opening to the right side. Moreover, we said that the distance from the vertex to the focus, which in this case is 2, it's going to tell us the value of P. And so we know from those 2 points, we know that the value for P is 2. So if we wanted to find the equation for the directrix, we could also do that because it will be also 2 units away from the vertex, but in the other direction. So the distance from here to here will also be 2, but the value that corresponds to that line, it's gonna be -2. And so the equation of the directrix, I know it's not a question here, but it could be on your homework, will be, it's a vertical line, that vertical line. So it's going to be x equals -2, just in case. So the standard form, since, well, going back, the vertex is at the origin. So the standard form for that equation and of the form that opens sideways, if you go back to your formulas, you could see here that it will be right here. Y squared is equal to 4px. And that is what we have written down here. So now if I just substitute the value that I got for p, it's going to be y squared is equal to 4 times that number 2 and then x. And so the equation will be y squared is equal to 4 times 2, which is 8x. And that's it. That's how you will leave your answer. Now let's look at the drawing here. So there is another way to graph it. And once you have your points, you have to find other points. Once you have your equation, you might need at this point you only have the vertex, so you need to know like how wide is it going to be open. Is it going to be like that, or is it going to be wider, or is it going to be narrower? So we're going to learn how to do that on the next problems. So for now, let's just take the example that we have here, and I know the directrix was not part of it, but I'm just going to add it to the drawing here. And remember, the distance from here to here is the same from the vertex to the focus. Now, for example 2, we're going to see how this will look like if the vertex was not at the origin. So now the vertex is at the point 2, 1. So I'm going to try to plot the points so I can get a good idea of what to do. So 2, 1, we have it there. That's the vertex. And then we're going to plot the focus. The focus is at 2, 4. So it will be here. So if I want to get the distance between the focus and the vertex, I could either count the units. You could see that it will be 1, 2, 3. Or I could subtract 4 minus 3 because they are separated vertically. The focus is right above the vertex, so that means that they have, and of course you can notice they have the same x, so you have to subtract the y. And that will be a distance, and this is completely wrong. I should be subtracting 4 minus 1, so that will give me a distance of 3 units. So based on that, we know that the value for P is going to be 3. Now, since the vertex is 2, 1, that is giving us the values for H and K. So this is telling me that H is going to be equal to 2 and K is going to be equal to 1. So now what we are going to do is get the correct formula. So in this case, we're going to have a parabola that is going to be opening upward. It's always going to open towards the focus. That's why it's important to find where the focus is. So I'm going to go back to the slide that has the formulas and show you which formula you will use. So we will be using this one, and we have x minus h squared equals 4p y minus k. So x minus h squared equals 4p. Actually, I'm just going to double check. 4p parentheses y minus k. And so you see, we already have all the values needed. We have h equals 2, so that we're going to substitute that there. We also have k is equal to 1, and that is coming from the vertex, actually. And then, so we're going to substitute that there. And then we found that P was 3 based on the distance from the vertex and the focus. So that will be substituted there. And that is how we're going to find the equation. So it's that easy. So x minus h, which is 2, equals 4 times P, which is 3, times y minus k, and k is equal to 1. Then we're going to multiply here 4 times 3. And that will give us 12. And so from there, that will be the answer. That will be the equation of the parabola. And if we had to, if it was part of the problem to plot the directrix, we will go from the vertex 3 units, the same number of units, but in this case down. So 1, 2, 3. And so we will have a point there. I'm going to just draw a line going across that point. This line will be the directrix. And the equation, because it's a horizontal line, will be y equals, and the number that corresponds to it is -2. There is a formula for it. I'm going to show it to you. So it's right here. It is k minus p. So if we do it that way, we could also use the values that we had here, 1 for k, and then +3 for p. So 1 minus 3, and that gives us -2. So that's another way to find it. You could always refer back to your formulas because not every single problem will be the same. So you have to figure out which formula to use and why, and where to substitute the numbers. So for this parabola that it will be opening up, we already discussed that. We could graph it, but we will also have to find 2 more points on it. And for example, you could assign a number to x and then solve for y, or pick a number for y and then solve for x, whichever you prefer. In this case, I would probably be curious about what happens, maybe not exactly halfway, but maybe when the y value is equal to 2. So if I was to substitute the y value with a 2, I'm actually going to get 2 cases. And I tell you that because we have 2 points that have the y value of 2. So if I say x minus 2 squared is equal to 12 times, remember I just randomly chose 2 for y, so I'm going to substitute this y value here, minus 1. And so I will get 12 times 2 minus 1 is 1. Oh, so I just have that. Okay. So then I will oh, Okay, I'm going to take the square root on both sides. And so here we'll cancel. So I will have x minus 2. Here we will have plus minus the square root of 12. And then if I want to solve for x, I will have to take that negative 2 across. So then I will have plus minus the square root of 12. And instead of minus 2, I will have plus 2. So from there, I have two values for x, one with the positive square root of 12. So the square root of 12 plus 2. And the other one will be the negative square root of 12 plus 2. And so those points are going to be, I'm going to just round them to decimals. And for the first one, I get positive 5.46. And for the other one, I get positive 1.46. So you could see that if we were to graph those points, they would roughly give us, let's see, if that was 2, it will be 3, 4, 5, 6. So we will have something, yeah, maybe here. And then we will have the other one at 1.46, so almost like 1.5, so maybe here. So what I'm gonna do, what that's telling me is that my parabola will be opening more, like a little narrower perhaps. Like that. And a pretty good way to check your work, it's you could use the Desmos app. And the very nice part of Desmos is that, or the website, is that you could enter x square or y square, it doesn't matter. Where in a graphing calculator, you always have to solve for y. So I do recommend that. I know some of you are already using it, so good for you. So the answer to this question, because I know sometimes that's all you care about, is this one right here. Okay, so now we're going to find the focus of a parabola based on the equation of the parabola. Now here, pretend we don't have the graph yet. So we know that it's going to be a parabola that is going to open downward because, well, first, for two things. First, the x is the one being squared, not the y. So it's either downward or upward. But we know it's down because the x squared has a negative coefficient. So the first thing we're going to do is just rewrite the equation so that we could work on that here. So y is equal to negative 1/2 of x squared minus x plus 1/2. Now, what we want to get to is to the equation. I'm going to go back to the slide with all of our formulas. And we want to get to something. We already established that it's going to be opening downward, so something like this one here. And so we want to get to something of this form. X minus h square equals 4p times y minus k. So we're going to copy that. Oops, I went too far. So x minus h square equals 4p and then y minus k. Now, since we already have y on the left side, I'm just going to reverse this formula. And also so that you know for sure that they are exactly the same. And so that is what we want to get to. That is our goal. That is our objective. So what we're going to do next is complete the square. And the first condition to complete the square is that the coefficient of x squared is equal to 1. So the way we're going to make that negative 1/2 disappear on the right side is by multiplying everything by negative 2. So if we have to do it to the right side, we are also gonna do it to the left side. So we're gonna have -2 multiplying the y as well. So that's gonna give us -2y is equal to, and if we distribute correctly, it will be -2 times -1/2, so that will be equal to 1. And that's why we chose -2, because negative is positive, and then we will have 2 over 2, so that is 1. So we'll have 1x squared. Then -2 times -x will be -2x, and then we will have -2 times 1/2, so that will equal to -1. And from there, we are going to, we will be adding a term, but before that, we're going to separate the constant term from the terms that contain x. So I'm just going to move it a little bit to this side. Now, what I'm going to do is consider the coefficient that I have here, -2. I'm going to take half of -2, so -2 over 2, and or let's just divide it. So -2 divided by 2 is equal to -1, and then we're going to square it. So again, this number is coming from half of -2 and then square it. So just like we're adding that number, once we simplify, you see that we will be adding a 1. So in this case, we're going to subtract a 1. Or simply, if here's positive, here it will be negative. That's how it will work. And we do that because it's like this little trick. If you add 1 and subtract 1, then it's like you added 0. And that's just one of the steps of completing the square. So I'm going to keep simplifying this. So -2y is equal to x squared minus 2x plus 1. Remember that -1 squared is +1. Then here we will have -1, and then minus, and then we have here -1 squared is +1, but we had this negative because we had to subtract that number. Now you can see that we're adding 1 and we're subtracting 1 because 1 minus 1 is 0. So if we continue working that way, we will have -2y is equal to x squared minus 2x plus 1, and then here we have minus 2. Okay, and what we're going to do next is we're going to factor this trinomial into a binomial square. And that is actually the whole reason why we do completing the square, so that we can factor it in a term that looks like this. Remember when we did the binomial theorem? So we need 2 terms inside with either a plus or a minus. And those numbers, the number is going to come exactly from here, from this number that we chose, -1. So that will go here. X minus 1 squared. And now this -2 here is kind of like on my way because I want to get to this goal where I just have a binomial square. And so I need to take that -2 to the other side. So what I'm going to do is add it. So it's going to be -2y plus 2. So it's like if I add plus 2 here, so they cancel. So I'm just gonna erase that part or delete it. And you can see that we're almost there to our goal. So what I'm gonna do next is I am going to factor out a -2. So if I factor out a -2, from here, I'm going to get y minus 1. And then my right side is still x minus 1 inside parentheses and then square. And that is exactly where we wanted to get. And that is the equation of the parabola. And oh, but that question was find the focus. So to find the focus, we need, well, let's go back to our slide with all the formulas so you know which one you need. And I believe we're looking at a downward parabola. So the focus is going to be given by this formula. Remember, the focus is a point, so it's going to be 2 coordinates. The x coordinate of the focus will come from h, and then the y coordinate will be k plus p. So h comma k plus p. So focus h comma k plus p. And that is because we're talking about a downward parabola. So the focus is going to become the point h will be, remember that is always the number that goes with x, so that'll be a 1, and then k is also a 1, and then to find the value of p, we have to consider that this constant -2 is representing, out of, I don't have no room, so I'm gonna have to shift this. So the -2 is actually representing 4p. So if we want to solve for it, it's gonna be -2 divided by 4, which is gonna be -1/2. So that is the value of p. So if we have 1 plus -1/2, that's gonna give us for the focus, it's gonna give us the coordinates 1 comma, and 1 minus 1/2 is just gonna be 1/2. So those are the coordinates of the focus. Well, that is the coordinate of the focus because we only have one. Once we go to the next sections, we'll have more than one. So that was the question. That is the answer, 1 comma 1/2. One of the applications will be a line segment that passes through the focus of a parabola and has endpoints on the parabola. It's called the focal chord. So sorry, not an application, but another definition. So if, for example, on this parabola here, if we were connecting, for example, a point here passing through the parabola, through the focus, that will be a focal chord. Now, if that focal chord is perpendicular to the directrix that I'm drawing here, and then that will be called the latus rectum. And it has to be perpendicular to the, in this case, to the major axis, or to the, in fact, I think I say this wrong. It has to be parallel to the directrix or perpendicular to the major axis, which in this case, it will be this line, the axis of symmetry, to be more specific, which in this case, it will be the line x equals -1. for the axis of symmetry. So the lattice rectum, which is here in pink, that has to be perpendicular to that axis of symmetry, and it will be parallel to the directrix. Parabolas occur in a wide variety of applications. For instance, a parabolic reflector can be formed by revolving a parabola about its axis, and the resulting surface has the property that all incoming rays parallel to the axis are reflected through the focus of a parabola. So, for example, in Cal 2, you will learn about what will happen if you were to rotate a line. And so if we were to rotate this parabola, right, with respect to the x-axis. So let's imagine that it's perfectly with the vertex at 0, 0. So if we were to rotate it with respect to the x-axis, like it's going in this way, so we will eventually create a 3D shape. So imagine that is a one of those old antennas, the gigantic parabolic antennas. That is exactly what it will look like. And nowadays we have like DirecTV and Dish Network, and of course those are like smaller um, devices, and they just tiny get attached to your roof um, or to the side of your house. So in fact, the place where they point the antenna and the direction that they direct it towards, it has to do with the focus and also, I guess, with the position of the satellite for that particular company. Um, so that is, one of the applications. Another one that I really like a lot, but this PowerPoint doesn't include a problem like that, is the lights in a car. Those are also supposed to be the place where the light bulb is. It has to do with the focus, and so that you can get the maximum light, I guess. And what else? A battery, of a flashlight. Yeah. So the place where the light bulb is, again, it has to do with that focus. And if you look inside a flashlight, without removing the glass, you could see how the inside is of a parabolic shape. So just so you know, the way that the the sun reflects or the signal is if you follow those dashed lines, they will hit the surface of the parabolic object and then they will bounce back to the focus. Or they could come from the focus, bounce on the parabola, and then out. One of the things that I used to do with my students was to make a solar oven, and we used to do it with a cardboard and then just make a surface, kind of like a 3D shape. And then we will position a stick and then a hot dog inside the stick. And then we will just let them cook outside. And believe it or not, they did cook. They even got brown. Um, and yeah, it had to do with the way that they were getting the sun. And the way that we positioned the stick was we actually found the focus of that. So it's pretty interesting. No, in fact, that's not the focus. The focus will be here. Yeah, here's the vertex. That was the focus. And then, in fact, the lattice rectum was be that line. That's where we position the stick. So another application is the tangent to a parabola at a certain specific point, and but does not cross the parabola. So it only touches it at one point. And this tangent line to parabolas have special properties related to the use of parabolas in constructing reflective surfaces. So perhaps you heard about a tangent line with circles, and it was just a line that touches the circle at one point. So I don't want you to think of tangent of theta such as y over x or sine over cosine. We're not in chapter 4 or 5. or 6 anymore. So tangent line, we're talking about those type of lines, and in fact they're like a huge thing when you take calculus 1, which I know some of you will do next semester. So a tangent line with a parabola, if we have a parabola, let's say like that, and we pick a point like that one, then a tangent line will only touch the parabola at that specific point and nothing else. So we have a better drawing here, as you can see. So here is the point, and the line that I'm about to highlight, that is the tangent line. And so the distance, okay, so that tangent line, if you extend it to the axis of symmetry that we see here, which is this vertical line, if you extend it so that it crosses that vertical line, and we mark that point of intersection, well, we could see that the distance from that point of intersection to the focus, I'm going to call it, let's call it D1. It is the exact same distance from the focus to the same point that we started with, that way. So the reflective property of a parabola, the tangent line to a parabola at a point, here's our point, makes equal angles, and you could see those are denoted by alpha. And equal angles with the following two lines. And so if those angles are equal and these two sides are equal, we actually have an isosceles triangle. And the line passing through P and the focus, that would be this one here. Oh, that one. And the other one, the axis of the parabola. So example 4 says, find the equation of the tangent line to the parabola y equals x squared and the point 1, 1. So the equation of the tangent line that we have to find is the equation for the line that I'm about to highlight. That line right there. So we know that that line intersects the axis of symmetry of the parabola at a point that we're going to refer to as 0, b. If you recall from chapter 1, you looked at linear functions in this form, mx plus b, in slope-intercept form, where this is the y-intercept, so that's why we say it's 0, b. The x-coordinate is 0 by default because it is on the y-axis. Also, we're going to end up using another formula, which is the point slope, and that one is going to come later on, but I'm just going to write it down here. So y minus y1 is equal to m times x minus x1. So that is point slope. Don't feel bad if you forgot about it. It's very common. But we call it point slope because we either need a slope, which is right here, or we have a slope, or we could get the slope if we have the equation, and we also either need or have or could find a point from that equation. So that's why we call it point slope. And then here, and just so you know, you're going to need to know this very well for calculus, so it doesn't go away. And this one is called the y-intercept form. I'm just going to rewrite it. Well, y-intercept form, or slope-intercept, I should say. That's the name. And again, it's because you have the slope, which is here, and then you have the y-intercept, which comes from that number. So what we're going to do here is first we need to acknowledge that it is going to be an upward parabola because the x squared is the one that is being squared. Also, from here, you could see how the vertex is going to be at the origin at 0, 0. And then we have that the focus is at, oh no, not the focus, but we have a point at 1, 1. So like that. Well, yeah, that doesn't tell me. But the fact that x is squared, yeah, that tells me. And also because the leading coefficient here is a positive number and in fact is a 1. So from here, if we were to write it in this form, 4py equals x minus, let's just use x. I mean, it would be minus h squared, but we already said h is 0. So we could just see x squared is here. And then here, instead of 4p, the coefficient of y happens to also be a 1. So it is 1 and then y. So for that reason, we have that 4p is equal to 1, and therefore p is equal to 1 over 4. So that is very significant because with that, we will know the focus of the parabola. And so the focus is going to have the coordinates 0, comma, p. And for that reason, it's going to be 0, comma, 1/4. And it will be this point right here. Remember that 1/4 came from the coefficient of y, and that 1 is equal to 4p. Solving for p, we get 1/4. So now what we're going to do to actually find what the point is, the point that we have here in question, because to find the equation of a line, we need two things. We need a slope and we need a point. And the only way to find the slope is with 2 points. So that's going to be another formula that we use. And for that, again, as this is from chapter 1, pre-cal 1, algebra 2, algebra 1. In fact, you probably learned this. Oops, I wrote this wrong. You probably learned this in, oh my gosh. Okay, my eraser is not working. So I apologize for that. It should be y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. That is a formula we're going to use. So we need two things. We need a slope, and then we also need a point. We already have a point because that is actually given to us in the problem. The point is 1, 1. So now we need to find the slope. So to find the slope, we need 2 points. So far, we only have this point, 1, 1. And that will be representing, I guess, x sub 1 and y sub 1. So what we need is the second point. And all we know is the x coordinate is a 0. So to find it, to find b, we're going to try to find the distance that I'm about to highlight. So one of those will be D2, the distance from the focus to 1, 1. And the other one will be D1, the distance from the focus to the point in question, the one that we're trying to find. So to do that, eventually we're going to end up equaling, since we know they're equal, we're going to equal the two equations that we get, which are the two that you see here. But before that, let me tell you how they found those. And so those were found by using the distance formula from section 1.9. And I believe we have used it in this class. So it's the difference of the x values square plus the difference of the y values square. So for D1, D sub 1, we're gonna have that our first point is going to be I just wanted to match here. So, okay, so let's say that this is our x sub 1, y sub 1, and then here we have x sub 2, y sub 2. So we're going to substitute into the distance formula, and we will get 0 minus 0 square, and then y sub 2, we have a 1/4, and then minus b. At this point, we don't know what b is, but we will find it later on. So nice thing here, this is 0, so we're just gonna have d sub 1 is equal to the square root of 1/4 minus b squared. So since we're squaring inside the square root, we could just cancel those two out, and then we will get that d sub 1 is equal to 1/4 minus b, and that is what we have here. So for d sub 2, the points that they used will be, so now to calculate d2, we're not going to use this, actually, yes, we are, the focus. And so, let me just think for a second. Yes, we're going to use the focus, and we're going to use this point, 1, 1, instead of 0, comma b. So in this case, we don't need this point anymore for now. And this is going to be our x sub 2, y sub 2, and the other point will be x sub 1, y sub 1. So if we substitute that into the distance formula, and here we're solving for d sub 2, we will have 1 minus 0 square and plus 1 for y sub 2 minus y sub 1, which in this case is the 1/4 right there. So 1 minus 1/4. And that is also square. So if we simplify that, we will get 5/4. So let's see why. Here we will have 1 minus 0 is just 1 square, 1 square plus, and 1 minus 1/4. Think of 1 as 4/4, so 4/4 minus 1/4 is 3/4 square. And for that, we will get, for 1 square is 1, and then for 3/4 square, it's gonna be, we have to square both, the 3 and the 4, so it will be 9/16. Now here, 1 in terms of sixteenths, it will be 16/16. So 16/16 plus 9/16, it's gonna give us 25/16. And the square root of a fraction is also the fraction of two square roots. So in this case, we could take the square root of 25, and that is 5. The square root of 16 is 4. So that's how we arrive to the fact that d sub 2 is equal to 5/4. So since we said from the beginning, we know that d sub 1 and d sub 2 are equal. So if we equal both equations, 1/4. So since we know that d sub 1 is equal to d sub 2, we replace d sub 1 with the equation 1/4 minus b, and then we replace d sub 2 with the number 5/4. So to solve for b, we could say, let's put the 1/4, let's leave the 1/4 there. We take the positive 5/4 to the left, so now it's negative. And then we take negative b to the right, so it's positive. And so b is going to be 1/4 minus 5/4, which is negative 4/4. So b is equal to negative 1. And I actually forgot what we were doing. Oh, it's right here. So b equals negative 1. Now that we know what that point is, and that was the point on the y-axis, the one right here. And we had a point here. So this was the one with the 0, comma b. So now we know the coordinates of that point are 0, comma, negative 1. And the other point that was given to us from the beginning was 1, 1. So now that we have 2 points and we want to find the equation of that line, first we find the slope. So here we have y sub 2, the formula for slope, y sub 2 minus y sub 1. So you could see that here, 1 minus, and notice how negative 1 is here. Well, b is negative itself. So we had to put it in parentheses. So we're doing 1 minus negative 1. That's what we're doing here. And then for the bottom, we're subtracting the x values. So that will be x sub 2, that's a 1, minus x sub 1, which is a 0. And so that will just give us 1. So on the top, we will have 1 plus 1. And then on the bottom, just a 1. So that's how we get a 2. Now that we know the slope is a 2, we know that m is 2. And we know that b is equal to negative 1. We could use the slope-intercept form, the mx plus b, and just simply replace the m with a 2 and the b with a negative 1. And that is just the final answer to the question, to find the equation of the tangent line in slope-intercept form.